Hi, this is Danet Vrazel, Vice President at KIN-TEK Analytical, and I'm going to go over a few things again with our FlexLink software. Today I've connected to FlexLink and I have three modules that I'm working with. With the FlexStream system, our FlexStream permeation system, we can include up to 6 modules in a series, and then we can operate those modules remotely using our FlexLink software. So today I'm going to quickly go over a couple of the modules that are connected to each other. As you can see, I'm in the Instrument tab, and I have the base module, which is the controlling module that is required to work with other modules. I have a PM1 and a PM2. So I have 3 oven modules here that I'm looking at. As you can see, as I tab through each one, I have a graphic that shows the temperature, the oven temperature set point versus the actual oven temperature. And I have an alarm on each one of those ovens. We can set the alarm to go off if it exceeds a certain temperature. So for example, if someone goes over to the physical instrument and changes the temperature of the oven and it goes beyond what the alarm setting is, the people surrounding will hear an alarm. We'll also get a visual alarm, and that's a safety feature that'll keep us from exceeding the temperature of the oven. So right now what I want to do is actually quickly change some of the temperature settings of the oven. So I'm going to go in here and I go under the permeation tab. I can still see those tabs of those different modules that I have physically connected to each other. I have nothing defined in my component tables. Each one of these has its own component table because I can put up to 8 permeation tubes in each oven. So on my PM2, you can see I have a helium tube defined here, and I have an emission rate. So we'll come back to that, but I have nothing defined in the base module or the PM1. So quickly, I'm going to actually change the alarm set point of our base module. I hit set for here over alarm limit, and I'm going to change this to, let's just say 60 degrees C. When I do that, I'm going to hit OK. That's going to change the setting here. So if I was to go above 60 degrees C on my oven, so if I wasn't thinking and a couple of days later I come through and I changed the temperature set point to 60 degrees C and I didn't realize that I had my alarm limit, I would hear an alarm. In the alarm state, the oven actually cools down, and then it'll cool down to a certain level, but then it'll start heating again and it'll hit that alarm again. So until the alarm's changed, it will not go above the alarm set point. I am going to change the temperature here. So let's just say that we have a perm tube that we're going to put in the oven. Let's just say it's calibrated at 40 degrees C. So we're going to hit OK here. That change will take effect here, and then we'll actually see the oven temperature start to increase in a short period of time. With that said, I would want to go and actually put my permeation tube in the oven and let it start heating up with the oven temperature change. So let's just pretend that we have a permeation tube. We're going to say we have something like benzene, okay? And let's just say we have a benzene tube that's 4,000 nanograms per minute. Put that there. And then real quick, I'm going to look up the molecular weight of benzene because I should know this off the top of my head, but I don't know it. So I'm just going to search that real quick. So if I did that correctly, it's 78.11 for benzene. Okay, the certification temperature I'm defining as my 40 degree set point. So I'm going to go ahead and put 40 degrees here. Okay, as I do that, I'm going to save that over to my physical FlexStream. You see this block diagram, I can hit save. It's going to save that perm tube property over to that FlexStream. Now I could do this with all the modules and then go ahead and save it over, but for demonstration purposes, I wanted to go ahead and save it over so that we know that that's what's taking place here. It checks each oven, and then it saves everything that is defined in each one of those ovens. So now that we have that defined, we can see up here our temperature is already starting to change to that 40 degree set point. And then it'll steadily increase. It is a PID controller for the temperature. And so as we finish getting this loaded over to the ovens, we can go back and look at our instrument tab and see here's our change here. So we were at 30 degrees C. You can see that change is now occurring in the oven. So as this increases to our set point, we have our oven set point change here, and then we have the actual temperature increasing there. Okay. On PM1, we're still at 30 degrees C here. At PM2, we're still at 30 degrees C. I can go back to my permeation tab. I can go to PM1, also put a component here. Let's just say we have toluene this time. And we want to go ahead and put in an emission rate for toluene. And with that said, let's just try something similar. We'll go with 5,000 nanograms per minute. Our molecular weight for toluene is 92.14. And we're going to just keep this at 30 degrees C. PM2, we're going to change the helium to, that was a test we were running. We want to do something, we'll say ethyl benzene, since we're going with the benzene toluene items. So, I'm sorry, not ethylene. We're going to go with ethyl benzene. So benzene, toluene, ethyl benzene, those are part of the BTEX package. And a lot of people use those for air monitoring applications. So the molecular weight for ethyl benzene is not 4, it's going to be 106.16 grams per mole. We're going to make this, let's call this, we'll say 8,000 nanograms per minute. Typically, you would find this information on your certificate of calibration. So that's how we would actually load that in, by using our certificate of calibration. Now that we have 3 of these defined, I'm going to go ahead and load these again. Just to check real quick, we are using 40 degrees C on our base module. So we are actually going to be trying to get to 40 degrees C here. Like I said, the PID controller typically will pass up the initial temperature and then it'll stabilize to that temperature. So it takes a little bit of time for the 40 degrees C setting to take place. As this loads, we also can point out that we can allow this to auto-save any changes to the FlexStream. This actually, as I updated everything and hit enter, started saving it over. I can actually save these tubes to a tube inventory file as well if I'm going to be using them quite often and pulling them out, putting them in my ovens. So now we have 3 tubes defined, 1 in each module. And if I go back to my instrument tab, I can check on again that temperature change. So we see we're almost to our set point. What it's going to do is going to try to align to that set point and see if we can pass it up a little bit. So we can visually see what's going on with that oven. And when we know that it's stable, we'll know when to operate with our perm tubes. So as we're doing this, just for the demonstration purpose, if I want to do a span by concentration, I can choose which module. So in other words, right here I have target source module is the base module. I can change this to PM1 and identify this as the module that I'm going to be using for the calculation for my calibration, okay, for that target component. So I'm going to target component number 1, which is in PM1, and I'm going to say I would like to have, let's just say 1 ppm, okay. We're going to hit go. It highlights that that's my target component and my target emission rate. And then if we go to the permeation tab, we can check that everything's stabilized there. And go to the instrument tab, we now see what our set point for our dilution flow is. So the instrument in the base module has a mass flow controller. That flow controller provides the dilution flow to give you your resulting concentration based on the temperature set point, the emission rate that we just put in, and that particular component properties that we targeted. Okay, so it took 1,216 cc's per minute to provide the concentration of PM1 that we provided. Okay, so now we can go and look at our data log. I can slide over and we can see for the base module, we can look at our concentration that we're getting. So we're getting 1.092, okay? And oh, sorry, that's for PM1. PM1 is our target module. We're getting 1.092. The PM1 data specifically shows us the primary dilution flows at 1217. These are points on our data table. And then we're getting 0.999 for the concentrations specifically out of PM1, the actual tube concentration. Okay, we can also look at PM2. So based on that flow that is consistent for all modules, because the mass flow controller is in the base module and then it's running through the series of modules, based on that set flow, these are our resulting concentrations. So the ethyl benzene is actually 0.025 ppm. That's how we know we can provide different permeation tubes in different ovens. We can put several perm tubes in one oven with the same temperature set point and get a variety of gas standards coming out of one system. So in one system, I have benzene, toluene, and ethyl benzene all operating right now. So 0.025 ppm of ethyl benzene, 0.999 ppm of the toluene, and then 1.137 ppm of the benzene. That would be my calibration gas going to my analyzer for calibration. So that's how I work with different modules in the FlexLink software with the FlexStream system. The next series of videos that I'll show, I'll vary these different modules and show you how to interact with a secondary dilution and even a humidified gas module. So please visit me on a different video and we'll go over more items related to the FlexLink software. Thank you.